friend. Today the discussing topic is about MCCB. If you not subscribe my channel, please subscribe my channel and press the bell icon for more information related electrical apparatus, electrical equipments, etc. Nowadays MCCB use has been increased due to its better protection. First we have to know what is the full form of MCCB. MCCB is molded case circuit breaker. It is also a circuit breaker. It is breaking the circuit during the different conditions but different fault situations. So it is an automatic device, operates automatically and manually both. Protect from overload and short circuit and surge current. MCCB is the advanced version of MCB. It offers extra features such as remote control, adjustable trip setting, etc. Used both low voltage and high voltage system. MCCB are typically installed in the distribution panel. Inside the substations, it is being used in the ACDB, that is AC, alternating current distributions board. Protection, it's being protection. We have already discussed short circuit and overload. It is an electromechanical device and its short circuit and overcurrent protection range from 63 ampere to 3000 ampere. By installing these types of protection inside a circuit breaker, it obviously enhances the operator safety. Now we start about the main components of inside the MCCB. Molding case. The molding case or frame is the cushion that keeps all parts of the circuit breaker in place. It is solidly built from glass polysters and thermoset composite resin that gives a great non-conducting strength. Molding case is the upper cover, that is hard plastics and made from polysters and thermoset resins. By help of these, any arcing or any type of flashings if will be there, no flashings and the fire can be out from the body, because that is totally non-conductive, and if you touch that time when the fault will be happen, no shock you will be get. So it is non-conducting strength is very high. Terminal is the serve as a connector. What is terminal? Where the input and output conductors or input or output systems will be connected. That is called the terminals. So it has 6 terminal, 3 in the input and 3 in the output terminal. The terminal serves as a connector between the external conductor and molded case. Upper the molded case, lower the molded case, and in between the connectors is theirs or are theirs. So in these connections we are just connecting the output and input. The external conductor and molded case, they should be connected properly to prevent the unusual heat productions. You should be check the tightness of the connectors, because if the connectors is tight, then no heat will be generated or no arcing will be there. If that is loose, because loose contact can produce heat, and that heat can burn or heat can melted the connectors also. Operating apparatus. This is the switch that's open and close. So MCCB has a switch that can on and off the circuit breaker. So this is the switch that opens and closes the molded case, and its handle connect the pull of the device and manual push. Trip unit. The trip systems is composed of temperature and current reactive electromagnetic electromagnetic sensor that trigger the operating apparatus in case of short circuit and overload. Its buttons can be pressed to reset the circuit breaker. So the trip unit can trip the circuit breaker when you will be needed for that. Application where we bring used the MCCB in the motor circuit, in the welding machine circuit, in the generator circuit, in the capacitors bank circuit, inside the substations and power plant. We are using it inside the ACDB, and from the ACDB we are providing the power to different area, different dB. Suppose as per the example, we are providing the illumination purpose 100 ampere or 63 or 32, or as per your illuminations lamp is there or are there. So in the substations we are separately just parallelly connected different types of different ampere rating of MCCB for different purpose. One is the illumination purpose, one is the battery supply purpose, one is the motor purpose, one is the filter machine purpose, one is the for the transformer purpose, breaker purpose. Inside the substations lots of BMK are there. BMK branch mechanism criox. See, this BMK has been powered by from the MCCB, from the ACDB of the substations, and from this BMK box we are connecting for the spin charging motor, illuminations lamp inside the circuit breaker kiosk, etc. So inside the substations and inside the power plant, for the power plant case we are providing the power to the street light, also providing the switchyard light, providing the boiler supply, turbine supply, generator supply, coal handling plant, and also the ash handling plant, and different area we are providing railway wagons area, different area we are providing the power by help of the MCCB for its lots of advantages. Now we are discussing about the type of the MCCB. It is very important, because if you don't know actual the type and you are buying an MCCB, it will not work properly. So for the proper function and proper application, which types of MCCB you have to use? So different types of MCCB are there: B type MCCB, C type MCCB, D type MCCB, K type MCCB, Z type MCCB. So what is B type MCCB? Tripping. It is depend on the tripping features. So if the 3 to 5 times of the rated current will be flow, the tripping time will be 0.04 to 13 second. Within this time period and within this time times of current from the rated value, these types of MCCB will be tripped, and actual these types of MCCB is being used for the resistive load purpose. If there is a resistive load, you have to choose the MCCB B type. And C type MCCB, if the C type MCCB 5 to 10 times of the rated current will be flow there, and the tripping time will be 0.04 to 5 second. Can be tolerate the high surge than the B type. The B type cannot sustain the high surge, and the C type can sustain the high surge, because if any systems has connected with the grid, connected with the lots of systems, lots of networks, huge amount of big and small fault can be there. So if there will be the small and big types of fault, so their surge will be there, the voltage peak will be there. If this surge will be there, this C type MCCB should be used. It is being used for the inductive load such as motor and transformer circuit. We are using these types of, because in the surge is coming to the motors and transformers because of the failures of the output lines. If the snapping of the conductor, lots of voltage surge or current surge may be there. So for inductive load we are using the C type MCCB. Now D type MCCB, if the circuit flow the 10 to 20 times rated current, if the fault if a one type of fault is present here, there should be 10 to 20 times current may be flow. So these types of circuit protection, we are using the D type MCCB, and the tripping type will be the 0.04 to 3 second. Within the 3 second, this circuit will be break, and the healthy part will be removed from the unhealthy portions. So the highly inductive load, very high inrush current, if very high inrush current and high inductive load will be there, that means the large electrical motor, for because the large electrical motor, we are using these types of motor inside the power plant, big industries. So the industrial companies or the big power plant, we are using this large electrical motor. If any fault inside the motors, there may be a chance of the huge amount of inrush current. So for that particular protection of that particular circuit, we are using the D type MCCB. K type MCCB. So K type MCCB, the same amount of rated current, maybe they are 10 to 12 time rated current, and the tripping time is 0.0425 second. Within the 5 second, that circuit should be operated. So the inductive load for that particular circuit where these features was there, if maybe there, so we have to use the K type MCCB. Z type MCCB, most sensitive MCCB. You should have to remember the most sensitive MCCB is the Z type MCCB. This is the tripping time 2 to 3 times rated current. If 2 to 3 times rated current will be below, this MCCB will be tripped. This is being used in the medical purpose or medical apparatus, sensitive semiconductor based medical or other expensive equipment that is vulnerable to the low current surge. If there be a chance, if something like that 2 to 3 times of the rated current will be flow, and if the 2 to 3 times higher current will be flow, the apparatus may be affected. So these vulnerable machines, we should have to use the Z type because this is very sensitive. And if any types of these types of problem will be there, this MCCB will be tripped instantly, and the circuit will be saved without hazards and without fire hazards. So now we discussed about the testing of the MCCB, different types of testing we have to do during the winter maintenance and during the pre-puja maintenance. We have to check that the MCCB is in good conditions, or in something like that inside some deterioration is starting. So we have to just doing our insulation resistance test of the MCCB. Contact resistance test, we should have to check the contact resistance. What is the contact resistance? If contact resistance will be deteriorated, then the current will be changes. Depend on the resistance, current will be changed. If the resistance will be high, current will be low. If the resistance will be low, the current will be high. So depend on the resistance, we should have to check the contact resistance. Tripping test, we have to check the tripping test by the tripping notch, that the circuit breaker is being tripped or not properly. Thermal protection test. Inside the MCCB, two type of coil are there. One is the thermal coil, one is the magnetic coil. A solenoid is present. One is the thermal protection, one is the magnetic protection. This is the main funda of the MCCB. Thermal protection, if lots of current, huge amount of current will be flow without the rating value. If the MCCB has been designed for the 2 to 3 times current, if the 10 times current will be flow, the heat will be generated, and heat will be bended the thermal strip, and that thermal strip will be disconnected from the connecting part, so the MCCB will be tripped. This is the thermal protection. And for the magnetic protection, if the lot of current will be flow, the magnetic solenoid will be energized, and if the magnetic solenoid will be energized, it will automatically trip the circuit breakers. And after this fault will be removed from the systems, if the current will be normal, then these types of magnetic solenoid will be deactivated, and if this solenoid will be deactivated, then the circuit will be normal, and the connector positions will be same as the current will be flow from the input to the output. So these two are the main point of the MCCB you should have to remember. So the maintenance, we are doing the maintenance little bit in the MCCB, required little maintenance because it is the maintenance free. It is inside the molded case, and arc extinguishers are also there. If you just maintaining opening the molded case, upper molded case, and cleaning inside the carbon deposits and the different types of hydrocarbons, this MCCB life will be enhanced. So the periodical maintenance and the visual checking and cleaning, it is too much importance. I have drawn a simple circuit for your better understanding, because inside the MCCB, if you open the molded case, upper molded case of the MCCB, two pocket was there. Pocket is there. The pocket are there. One pocket you can connect the shunt coil, and the other pocket a NONC contact. What is the function of the NONC contact? It is being connected to the DC source, and the shunt coil is being connected to the AC source. It is single phase. We are just draw a pictures of the shunt coil. Two pocket are there. If this is the MCCB, this is the inputs, this is the outputs, and the inside all the mechanisms are there. Two pocket are there. One is here and other is here. Here the switch on off switch, and this is the connected with a mechanical latch. This is also connected to a mechanical latch. Okay, we have to place here the shunt coil, and this shunt coil, we are just drawing a shunt coil diagram. This shunt coil is connected to the 220 volt AC supply single phase. This is emergency push button operation. Emergency push button, push to close. If you wants to on or off this circuit breaker or MCCB from the remote control, from inside the control room, you should have to just extend these conductors to the panel. Which types of panel you will choose, and you have to push the push button and particular circuit name, and then if you push this button, this voltage will be there and this coil will be energized. If this coil will be energized, this latch will be just cut it. So if you push, it will be on. If you then push, it will be off. Emergency off. Okay, so emergency push button off switch, emergency off. If you push it, it will be off the circuit breaker or disconnecting. As like as this shunt coil, this is the shunt coil. We are putting the shunt coil here, we are putting the NONC here. The NONC, if you are just providing the DC supply, a notch is outside. If you just manually during the testing, if you just touch this up, then this circuit will be tripped. This circuit will be tripped. As like as this NONC contact and latch is connected to the controlling connecting path of the MCCB. So if this connecting path will be energized, this NONC contact will be energized and that will be tripped. So this is the main two function. Another two advantages of the MCCB, firstly we discussed about it can be used. We have discussed that the MCCB is an advanced version of MCB. It's offer extra features such as remote control and adjustable trip setting. It is very important. Remote control, by help of the shunt coil, we can use the remote control operation. And for the adjustable trip setting, means there has a notch. I will attach a MCCB pictures you can see after my video, which is the adjustable trip coil and which is the adjustable trip setting. There trip setting means a round type notch will be there. Here 100, 80, 70, 60, 50. These types of, and one notch will be there. If you are connecting the 80%, so it will be treated as an 80% current will be flow, then that will be trip. With 100% current will be flow, then trip. If 70% current will be flow, then trip. So this is the trip setting. So friend, this is very important topic MCCB, because this MCCB is being used nowadays different area of our protection circuit inside the substation, inside the power plant or the big industries, small industries, small scale industries here and there. So friend, if you interested, please subscribe my channel and press the bell icon for more updated and more these types of related knowledge with the friend. So I will attach a MCCB pictures with this video. Please see this video for clear understanding. Thank you friend, thank you for subscribe my channel and share my channel.